Right, hey guys, I've realized that there's a problem because everyone's in my previous one that I've just ended and they're going to have to swap over. I'm hoping they're going to have done it automatically, but we will see. How entertaining is that? Right, let's do the register. I'm not set up for this now because I ran right to the wire with my year 13s. Sorry about that, guys. I'm never meant to do that, but you know, it's hard not to at times. I want year 11 register. There we go. Now, technically, this is meant to be our last week. Hey, everybody. Hey, everybody. Right, hang on. Course registers. There we go. I'm nearly there, folks. Sorry about this. Give me a sec. It is Wednesday, the 17th of June. Amazing. So I've got Adam. I mean, Adam's been there for ages, but he's now no longer in this one, which is your year 12 class sounds confusing. What do you mean? Your year 13s. Okay. Nah, do you know what, Julian? Everything makes sense. You just probably caught the end of it. Yeah, you've got to, and you need the previous bit. And once it's not that hard. Honestly, it really isn't. Really isn't. I've seen Adam, of course, but he's now no longer here. Do I have Angel? No Angel yet. I haven't seen Angel in a while. Anch is here, of course. Aisha? Do I have Aisha? Not that I can see. Got Alistair. Isha? I haven't seen Isha yet either. Emmeline, I've seen. Hermione, I've seen. Mel, I've seen. Manisha, I've seen. Minwi, I've seen. Misha, I've seen, I believe. There's Isha. Amazing. There's Isha. Yeah. Aisha? I haven't seen Aisha yet. Murdo's not coming anymore. Julian, yeah. Oliver, yeah. So I'm just missing, I believe I'm just missing Angel and Aisha is what I believe. This is where I've got to go and find my other lesson. Just missing Angel and... Get rid of that. What's up, Mr. Duncan? Yo! I love it, Adam. That's amazing. That's brilliant. Also, OTW. I don't know what that means. On the way. Aisha's on the way. Oh, DWS. I don't do all these acronyms. I don't know what they mean. Ugh. It's really funny. Anyone seen Angel? Oh, no Angel. Aisha's on the way, is she? Okay. Right. I will leave it there for the register. Right, guys, let's crack on. So today's lesson, you've all seen it. Like, we need to go through the homework. And do you know what? With me literally running my year 13 lesson to the wire meant that I'm not entirely set up for this. Oops. Let's go for that guy, that guy. Okay. Yeah, by the way, the lesson really wasn't that confusing. It's just the extension of what you did in Equilibrium from GCSE, really. It's not even that hard. Right, you guys have got 2 homeworks that we need to go through. And I haven't even put my lesson in yet, which is a nightmare. Lesson, oh, let's go for AS. Oh, I mean, this is going to take me ages. Oh, stuff it. Just going to do it like this. AS Calcs lesson 12. And this is excess reagents, really. I'm hoping I'm going to get to it. Excess reagents. We started doing, and by the way, everyone struggled with that. I wanted the answers to the PQ, but I was going to get hate if I got the wrong, so I didn't. To the pressure question. Oh. Don't be silly, Adam. You can do whatever you like. I don't mind. It's nice to see you contributing. There's Aisha. Amazing. Right. Got 2 homeworks. Insert. Print out. I can't even remember which ones I set you. These are my A-level homeworks. I sent you guys 2. I gave you guys, oh no, which one was it? Reacting mass homework 1, I believe. Let's do that one first. I think that's correct, doesn't it? Set you 2 homeworks, guys. Come on. I'll try and be as quick as, but there's a chance that I will just end up doing these. I can't remember how many I gave you. Eek! The answer is quite a few. Okay, now the idea was to kind of see real reacting was not able to do question 1 on the yield as part of the info was cut and not visible. Oh. In which question? Question 1 of percentage yield. Oh, okay. That's possible. That is possible. I don't, yeah, just, that's fine. That's fine, Oliver. Don't worry about it. I'll see that in a minute. Calculate the volume measured at the gas pressure. Okay, right. So they've given me 5 grams of barium nitrate, 5 grams of him. Right, step 1, get to moles. Number of moles is grams over rams. Yeah, because I'm in grams, so that's the equation I'm using. I'm going to be trying to be as quick as possible. Yeah, so number of moles is grams, 5 over. I need to work out the MR of barium nitrate. Blimey, no idea what barium is. Barium's massive. A-level table. Come on, barium. 137.3. Wowzer. So barium nitrate, 137.3 plus 14 times 14.0 times 2 plus 16 times 6. Blimey. Yeah, remember the 0.3 is really what matters there. So 137. I'm not going to get onto excess reagents here. Plus brackets 14 times 2 brackets plus brackets 16 times 6. So easy to make errors on these things. 261.3 grams over rams. 5 divided by answer gives me 0.0191 moles, but I'm keeping it on my calculator. Real number 0.019135093. Yeah, step number 2, use the ratio. Right, what am I trying to get to? Total. Oh, it's a game. Look at this. This is what I mean by it gets harder. Right, guys, the total volume of gas. Right. Now, guys, this is where things become tricky, because look at the equation. The ratio of this guy is a 1, but to the total volume of gas. What that means is to 2.5. This is a 1 to 2.5 ratio, because it's the total volume of gas. It's all of these guys, not an individual person. This is what I mean by combining equations and this harder idea of concepts of using equations. So the ratio there's the mark. Lots of people will miss that mark. 1 to 2.5, and I'm moving in this direction. So I'm going to multiply by 2.5. There's my number on my calculator. So I'm going to go times by 2.5 equals. So that equals 0.0478, keeping the number on my calculator, moles of total gas. Yeah, there we go. Step number 3, get out of moles, and it asks me for the volume. And look, they've given me a temperature and a pressure. PV equals nRT. Rearrangement, it's asking for a volume. Therefore, volume equals nRT over P. Insert my numbers. Moles, 0.0478 multiplied by 8.31 multiplied by the temperature of 298 all over the pressure of 100,000, because you have to do a conversion. Yeah? So that number on my calculator times by 8.31 multiplied by 298 gives me, divided by 100,000, gives me an answer in meters cubed, 1.18 times 10 to the minus 3 meters cubed. Final answer, ticket. Yeah. God, guys, look at the number of marks that's going to be worth. That's going to be worth, just to let you know, that is worth 1 mark for that, 1 mark for that, 1 mark for the ratio. Yeah. By the way, if you've done that mark without writing that down, you lose it. Yeah. That's consequential on the ratio. And then the final answer with PV equals nRT, yeah, in meters cubed with the correct units. So that's going to be actually a mark for the equation reorganized as well. So total marks is 5. 5 marks for that. Big question. Next, right, calculate the volume of, again, do you see what they're doing? They're blending, right, guys, I've never mentioned this to you guys. I hope you guys looked it up. Yeah, so I need to mention this. You're going to see these questions, but you can never use it. Moles per dm cubed, yeah, moles per dm cubed can also, can also be written as a capital M. This stands for molar. Molar. Yeah. Now, can I just point out, this is an old unit. Old unit. You guys, you're going to see it, but you're not allowed to use it. You must use moles per dm cubed. Yeah, you must use this guy, but you're going to see it, but you can never use it. It stands for molar, which is moles per dm cubed. Yeah, moles in a liter. It's an old unit. You'll use it if you ever go to university and do anything to do with science. You'll see that all over the place because they refuse to use anything else because it's easier to say, just molar. Yeah, but it means moles per dm cubed. It means the same thing. So I hope you guys looked that up. Right, calculate the volume of. So we now know that this is a concentration. So, and we've been given 5 grams of barium nitrate. Yeah. So it says calculate the volume required to neutralize oxide formed when it decomposes 5 grams of barium nitrate. Oh, hang on a minute. This is an extension of the previous one. Calculate the volume of hydrochloric acid, which is required to neutralize exactly the barium oxide formed by the 5. Right, guys, this is an extension. What we realize is up here that, what do you notice? We've got 5 grams of barium nitrate here. Well, the great thing is we've already done half the work. That's in a 1-to-1 ratio. So the moles I had for barium nitrate are the moles I have for barium oxide. Yeah, moles of barium oxide, of BaO. Got to be careful though, because what's going to happen is I'm going to end up with a rounding error if I use that. So what I'm going to have to do is run this calculation again. Yeah, 5 divided by 261.3. That's why if you do this all properly, yeah, the moles of barium oxide are 0.0191 because it was in a 1-to-1 ratio with the barium nitrate. Yes, that's clever, this game, guys. This is where everything gets so much harder. Yeah, moles of barium oxide. Right, what's the ratio? Step number 2 is the, so I'm going to see if I can zoom out a bit because, oh, my laptop's gone and paused. Yeah, this is step 1, get to moles. Step 2, use the ratio. The ratio is a 1-to-2 to the hydrochloric acid, and we're moving in this direction. So we've got to times it by 2. So therefore, that equals 0.0191, or the number on my calculator, times by 2. So I'm going to times that by 2, and I get 0.0383 moles of hydrochloric acid, of HCl. Now, they've given us the concentration. Step 3, get out of moles. Number of moles equals C times V over 1,000, because I'm going to give me it in centimeters cubed. Yeah, I want the volume. Therefore, moles times 1,000 over the concentration will give me volume. I've already got the moles, so therefore, 0.0383 multiplied by 1,000 divided by the concentration of 1.2 molar, yeah, times 1,000 divided by 1.2, and I get a volume of 31.9 centimeters cubed, and we're done. Ticket, massive marks. Yeah, that's really interesting because what they're saying is, look at that, total marks is out of 7. Well, that actually makes sense. 5 for the previous section and 2 for this one. We've already got the moles from the previous equation. There's 1 mark for that and 1 mark, there'll be 1 mark for the rearrangement. Yeah, I'm actually going to give you more marks than that, to be fair. They actually give you 7. That means there's clauses all over the place. Yeah, it's a bit of a nightmare. I'm actually going to give you 3 for that. Ignore the marks. I'm going to give you 3. Yeah, next. Right, so this was just us having a go at the previous questions that we were doing. The mass of 1 atom of carbon-12 is this. Use the mass to calculate the value of Avogadro's constant. Show you're working. Right, hang on a minute. So 1 mole equals Avo. Yeah, equals Avogadro's constant. Well, we've got the mass of 1 atom in grams. Well, 1 mole is also equal to the AR in grams. Yeah, and carbon weighs 12.0. That's the leap of faith. Yeah, 1 mole of carbon is equal to 12 grams. That means 12 grams equals, yeah, Avogadro's number. We can also say that equals Avo. Good old Avo. Yeah? Well, hang on a minute. We know that Avo is the total number of atoms. So if we just divide that by the mass of 1 atom, we're going to get Avogadro's constant. 12 divided by, it'd actually be 12.0. Yeah, 12 divided by 1.993 exponential minus 23. And I get an answer of, and that's the important bit, 6.021 times 10 to the 23. And we're done. Dun, dun, dun. Dun, dun, dun. Amazing. Hope that makes sense. 1 mark for that guy. Next. I'm never going to get onto excess reagents. Not that it matters. I don't care. We've got. I know that. I'm going to finish off doing the calculations webinars when you guys are meant to be in lessons anyway. So even if you decide not to show up, that's totally up to you. I understand. Yeah, I'm not going to put any requirements on that. I'm assuming I'll get nobody watching. But once, I think this is meant to be the last week. That's what I'm saying. Ammonium nitrate can be paired by the reactions between ammonia and nitric acid. The constant. Oh, now they've been nice and given us the real answer. You've given us the real concentration units. So calculate the volume of solution which is required to. They've given us grams. Okay, so step number 1, get to moles. Number of moles is grams over grams. If you ever see grams, you're probably using it. Therefore, moles equals 20 divided by the MR of ammonia. Well, ammonia is 17.0. Yeah, just to tell you why. Nitrogen is 14.0 times by 1 plus hydrogen at 1.0 times by 3. We know this. So 20 divided by 17 gives me equals to 1.176, which are 3 sig fig, 1.8, there we go, moles. Keep the number on your calculator. What's the ratio? It's asking for the volume of nitric acid. Yeah, so it's a 1-to-1. If you don't write it down, you will lose that mark. Yeah, it's a 1-to-1 with nitric acid. So the moles is the same. Therefore, 1.18 moles of nitric acid, HNO3. Right, get out of moles. Step D, what am I after? They're after the volume. Number of moles is C times V over 1,000. Reorganize. Moles times 1,000 over C gives me V. That's easy. Got the moles on my calculator already. 1.176470588 times by 1,000 divided by a concentration of 2, and I get a volume of 588.2, don't even need it, centimeters cubed. And that makes sense. Yeah, it makes total sense. Take it if you got it. How many marks? Done one in black, one in red. I'm going to switch to my green pen for marking this one then. Yeah, let's go for dark. 4 marks, it says. That's 4. So 1 for 17.0, 1 for the moles, 1 for the ratio, 1 for the final mark. We're done. Next. Okay. A sample of ammonium nitrate. I'm going to switch to black. Shouldn't really be flipping between my colors. Yeah. Ammonium is decomposed on heating, on cooling. The resulting gas is 298 meters cubed pressure, yada, yada, yada. State the ideal gas equation, PV equals nRT, 1 mark gained. Use it to calculate the total number of moles of nitrogen and oxygen formed. Oh, that's interesting. So first of all, we need a rearrangement. Number of moles equals PV over RT. Yeah, I hope everyone's, because all I'm doing is dividing both sides by RT. Hope you figured that out. Yeah, there we go. So now that I've done my rearrangement, I don't want to do that though. I just want to leave that like that. I quite like seeing the rearrangement being done. So next, total number of moles of oxygen made. Right, so hang on a minute. On cooling, the resultant gases. So they're saying the result, which is the volume of oxygen and nitrogen together. So these guys together was found to be the pressure. Let's just insert my numbers. Yeah, number of moles equals pressure, 95,000. Got to remember to do the conversion. Yeah, you're not allowed to add 95. You have to convert it to pascals. So times by 1,000. The volume is already in meters cubed. That's nice. Thanks very much. That's really nice of you. No conversion needed. Over 8.31 multiplied by a temperature of 298. So let's run it through. 95,000 multiplied by 0.05, which is very nice. Then divided by brackets, 8.31 times 298. Oh, I've missed my decimal place, my little point, my point thing on my calculator's dodgy. 298. I put that in a bracket. So I'm going to get an answer. Number of moles equals 1.92 moles of gas in total. Cool. It then says the total moles of nitrogen oxygen formed. That's fine. That's nice and easy, isn't it? So 1 mark for the rearrangement, 1 mark for the conversion, and 1 mark for the final answer. 3 marks there. Next, using your answer to part BI, deduce the number of moles of ammonium nitrate decomposed and hence calculate the mass of ammonium nitrate in the sample. Right, well, hang on a minute. That's not too difficult, is it? Because we've just worked out the number of moles of this guy. That's what we've just worked out. Well, the ratio is 1.5 to 1, and we're going in this direction. Yeah, so the moles, this is going to be worth 2 marks, and there it is. The ratio is 1.5 to 1, and we're moving in that direction. So we're going to take our number of moles of 1.92, and we're going to divide by 1.0. That's interesting. It's the same as a 3 to 2. Divide by 3 times by 2. Divide by 1.5 times by 1. Lol. So it's just divided by 1.5. Is that right? That's weird, isn't it? 1.92 divided by 1.5 gives me 1.28. Yeah, that's correct. Divided by 1.5 gives me 1.28 moles. It's an interesting, clever thing, that, isn't it? I don't like that. I don't like the ratio the way it is with that. It's weird. But it makes sense. I'm making less, making a third less, aren't I? That makes sense. Okay, so there's 1 mark for that guy. And then the mass of ammonium nitrate, number of moles is grams over rams, but now we're asking for grams, so reorganize. Therefore, number of moles. Oh no! 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 Number of moles. Oh, it's gone and done it again. Close that down for a minute. See if I can bring it back. I may have to just restart my computer. I don't know why it does this, but it does. I don't know why. I'm hoping this is going to fix it. Every now and again it fixes it. Every now and again it doesn't. Fixed it this time. Go figure. So number of moles times by rams gives me grams. So 1.28 times by what does ammonium nitrate weigh? Yeah, ammonium nitrate, yeah, NH4NO3. That is nitrogen at 14.0 plus brackets, hydrogen 1.0 times by 4 plus nitrogen at 14.0 plus oxygen at 16.0 times by 3. Add it all together. 14 plus 4 plus 14 plus bracket 16 times 3 gives me 80. So times by 80 gives me 1.28 times by 80. Guys, if I make a mistake, by the way, please let me know. 102.4 grams. I'm done. I'm done. Next. This is just going to be a homework review. Am I nearly at the end or what? Blimey. It's been tough, man. Next. What is the name given to the number of molecules in 1 mole of carbon dioxide? Avogadro's number. Avogadro's number. State the ideal gas equation. PV equals nRT. You are putting many of your answers to 4 sig fig. Many? I wouldn't say many. Do you mean 1? Okay, Avogadro's I've given to 2, given to 4. All right. I've given 2 answers, Oliver. Come on. Is it okay if we give it to 3? Yes, absolutely fine. Unless they state otherwise, it should be, they'll give you the 4, though they won't care. But yes, it should be the 3. You're absolutely right. Apart from Avo. Avo, you should definitely quote it to 4 because it's what makes it different from the number that you've learnt. That's a trap, that. Yeah, if you did that, they'd probably give it to you anyway. But it's what separates it from the 6.022. That's all. It was meant to be there to trap that one, but I don't think they'd care in reality. Yeah. That one, I just think it's good. It's a good practice to do so. Yeah, I don't know. But yeah, that's fine, Oliver. It's absolutely fine. Calculate the volume of 1 mole of carbon dioxide at... Right, okay, calculate the volume. So I've already done... Right, they've already got that mark. Need to do the rearrangement. Yeah, V equals nRT over P. Yeah, just divided both sides by P. That's all I've done. Right, the number 1 mole. So 1 mole times by 8.31 times by 29. I said 9. I wrote down something else. 298 Kelvin all over 100,000. There's your conversion mark. Yeah, so 1 multiplied by 8.31 multiplied by 298. Yep, divided by 100,000 gives me, right, and this is going to spit out in meters cubed 0.0248 meters cubed. It's just nice to show you. If you times that by 1,000, yeah, it'll give me 24.8 decimeters cubed. So guys, do you remember V over 24? Boom! There's V over 24. There's V over 24 for you. Oh, my pen's doing it again. No! Don't do it to me. Don't do it. It's doing it. It's doing it. I'm gonna close that down again, see if I can bring it back. It's gonna continue to gain faults. I don't know what's going on. It's definitely not my pen, it's definitely V over 24. No, it's gonna fail now at this point. We have to restart. Nightmare. But it should be, so now people going, so shouldn't it be V over 24.8? Yes, it should. So why isn't it? Because 24.8 is hard to remember. That's it, you're done. Isn't that nice? Should actually be 25, shouldn't it really? Round up. Don't know why they don't. Calculate the mass of carbon dioxide gas at, they've changed it. Right, calculate the mass. Okay. Oh, clever. I need to get to moles. PV equals NR. My laptop is now hiccuping all over the place. I now need to work out moles first. Therefore, I don't know what's going on here, guys. I don't know what's going on. Number of moles equals PV over RT. Pressure, 500,000, just slowing down, times by a volume, and it's given us it in meters, which is rather nice. Oh, how easy it would be there to miss a number. Yeah, over 8.31 times by 273. Sorry, guys, my laptop has got this stupid fault. 500,000, counting my zeros on my calculator, multiplied by 0.005 equals, divided by brackets, 8.31 times by 273. 273, got it. Easy to make calculator errors. It's going to give me moles. Moles equals, oh, come on, laptop, 1.10. It's slowing me down massively. Moles of CO2. Yeah. Then I go, what mass of it is it? Number of moles is grams over rams. Moles is grams over rams. Carbon dioxide weighs 44.0. Just restart it. Yeah, I will do in a minute, Anch. Yeah. So reorganize that. Moles times by rams. Oh, gives me. Oh, it's proper gone now, guys. It's just going. I'm going to close that down one more time. Give that one more try. One more try. So moles times by rams, it's not making any difference. Oh, right as I was approaching the end of it. Right, guys, I'll be back in literally 60 seconds. Time me. Restart. I'm back. Share screen. Let's get back to it, guys. I'm sorry about this. I can't honestly explain to you why it does it. It just sometimes it just needs to be restarted. Really strange. There we go. I'm back. Sorry about that, everybody. I cannot do anything about it. It just all of a sudden decides to cause me trouble, and it'll now work just fine. So I've got 1.1 moles of CO2, number of moles, times by rams gives me grams. Carbon dioxide, of course, weighs 44.0. If anybody's not sure as to why, carbon 12, oxygen is 16 times 2. So 1.10 multiplied by 44 gives me it's on my calculator, times by 44. Oh, syntax error. Oh, times 44. There we go, gives me 48.5 grams. And we're done. Tick it if you got it, folks. Yeah, tick it if you got it. If you want to have all the marks here, guys, because we need to be adding them up, don't we? That total was out of 7, really, but let's have a look at what I give you. Yeah, so 1, 2, 3 for the rearrangement, 1 for the conversion, final answer in meters cubed or DM, either one that you want. Yeah, sorry, hang on a sec. There we go. Next one, yeah, conversion, equation, you can't get it because you've already done a rearrangement. Rams and grams. How many marks is this out of in total then? 1, 2, 3, 4, 5, 6, 7, 8. I'm giving you it out of 8. So I'm going to give you it out of. Next. Last question of this homework. I'm just going to do the homework review today, and I'll change all my title of my lesson. Okay, so what mass of hydrogen is formed when 100 centimeters cubed of hydrochloric acid reacts with 5 moles per dm cubed with excess magnesium? God damn it, excess reagents. But in reality, it's telling us not to use it. So what mass of hydrogen, is when 100 right? So they've given us number of moles equals C times V over 1,000. How do I know that? They've given me a volume and they've given me a concentration. Run it through. Yeah, just run it through. Concentration is 5 times by a volume of 100 all over 1,000 because I'm in centimeters cubed. 5 times 100 is just going to be a half, isn't it? Divided by 1,000 gives me 0.5. Yeah, that'll give me 0.5 moles of hydrochloric acid. Look at the ratio. Yeah, next mark. Got to write it down. It's a 2-to-1 ratio, and we're going to magnesium, going in that direction. Yeah, this is HCl to Mg. So divide that number by 2. Divide that number, therefore, 0.25. Oh, no, hang on. It's not to magnesium. It's to hydrogen. Yeah, oh, but it's actually the same ratio. Lol. Yeah, so I get 0.25 moles of H2. Right, it then wants what mass of hydrogen? Number of moles is grams over rams. Hydrogen, of course, weighs 2.0. Number of moles times by rams gives me grams. So multiply that by 2, and I get an answer of 5 grams. Yeah, 0.25 multiplied by the rams of H2 is 2.0 equals 0.5 grams, and we're done. Tick. 3 marks. Yeah, moles, ratio, answer, you're done. Perfect. Right, total marks for that, 3. So total marks for this homework, I've missed the marks in for the central one here. So that one there was 4. This part here was, got to work out the rams. Did I write it down? Oh, I lost a mark. 80.0. I lost one. Had to be 80.0, remember. If you do that, got to be careful. Yeah, so 80.0 is a mark as well. Oh, it says total for this one is out of 6. Oh, yeah, exactly what I gave it as well. Yeah, 4 for that, 6 for that one. 6, and then 1 for this guy, annoyingly. Right, 5, 3, 5 plus 3 plus 1 plus 4 plus 6 plus 8 plus 3. Total out of 30. Out of 30, guys. Check it, add it to the sheet. Got one more homework to go through. I've realized this is just going to be a homework review. God, that's out of 30. That was really hard, folks. God, are you guys, I really can't wait to see what your scores are like. If you're able to do this, I feel like I haven't done an awful lot. Those were hardcore reacting mass calcs. Like, seriously, guys, full-on hardcore. God, I'm really worried that I'm going to be setting you guys work here that's too hard. That's kind of freaked me out a little bit. I hope I haven't. I hope you guys have done okay on this and you're not feeling like you're struggling at all. That was a really, if you can do that, God, you can do most of what they throw at you. Let's see if we can find your homework sheet. Out of 30 for reacting mass, homework 1. And then I'm just going to do a homework review on this. And then this is the great thing about doing all these things online and stuff. It's going to be super useful for me in the future. So year 11 homework tracker. See how we get on. Wait, look at this. Wow. Manisha, 24 out of 30. Outstanding. Aisha, 22. Not bad. It's not bad, you know, guys. God, these are really good. I'm really happy with this. It's really hard. That was way too hard, really. Considering I haven't done an awful lot of lessons on this, guys. Well done, Emmeline, 25. Great result. This is hard. Anch, 19. It's a great score, Anch. That's a good score. If you're able to get any of the guys, that homework was probably too hard for what I'd done with you guys already in lesson. Julian, 21. Well done. Good score. Can someone do me a favor and put a title in? My laptop's being a pain. Just put in a title of reacting mass homework. 25 from Misha. Well done. 25 from Emmeline. 25 from Hermione. Well done. Oh, guys, I'm so proud of you guys. This is hard, man. Oh, Murdo's kind of gone, hasn't he? I think Murdo's gone. Oh, thanks, guys. You're doing great. Adam, 20. Anch, 19. Julian, 21. Is that Murdo? Is Murdo here? Oh, sad face. Oh, that's funny. Who was that? Oh, Adam, I agree. I miss Murdo too. Oh, he's a good egg. He's a good lad. It's nice to see results going in. Right, guys, let's do the next homework. Let's do the next one. Blimey, can I do it all in one? Let's see if I can click there and go insert, print out. Don't know what it's doing. It's not, oh, it is doing it. It's just doing it really slowly. Is this like turned down on power? No, it's on best performance. That sucks. Percentage atom eco. I think I must have made a mistake on question number 1. We will see. Right, next homework to review. I'm sorry that I gave you 2, guys. I hope you managed to get them done. I promise you they'll make you better chemists. You notice that I'm basically like creating all of these now bespoke for these lessons. Come on, computer. It really is struggling. There we go. Atom economy. Right, let's go. Right. Questions. Okay. Calculate the percentage atom. Oh, it's cut the picture off. Oh, no. It's cut the picture off. Drat. Can you still do most of them? Amazingly, most of them seem to have kept it. Oh, nuts. Okay. So, in fact, there's just enough. You could have looked it up. You could have looked it up. Cyclohexanol forms cyclohexene by the following reaction. That sucks. Okay, I'll quickly show you. Cyclohexanol forms cyclohexene. Okay. Oh, that really does suck. Okay. So cyclohexanol. Yeah. I hate that picture. Hate it. Forms cyclohexene. And water. There we go. So it then says calculate the percentage atom economy by mass for the production of cyclohexene. You just have to make water as a byproduct. That's all. It's just this is dehydration, yeah, or elimination in this case, to make an ene. So I know, and I'm hoping that you guys probably would have looked it up. Yeah. So atom economy. So we've got my marks here, and look at the space you've been given. So percentage atom eco, I'm just going to do it anyway, even though you might have skipped it, equals wanted over total out. I teach total out, some teachers teach total in, times 100. Therefore, right, hang on a minute, cyclohexene. So it's got 6 carbons. This is clever, this, because this has got carbon, 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 2 hydrogens, 1 hydrogen, 1 hydrogen, 2 hydrogens, 2 hydrogens, 2. This is skeletal into displayed, which is a bit of a tricky one. Yeah, so 12 times 6, yeah, 72.0 plus 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 plus 10, 82. So I've got 82.0 for my wanted, 82.0 over total out, just add it to 18. 82 plus 18. Yeah, which gives me exactly 100. Nice. Times 100. 0.0 equals 82%. That's not bad. 82.0% if you prefer. Yeah, 3 sig fig. Should always do to 3 sig fig unless stated otherwise. Yeah, so that's 82.0%. I like it. Tick it, 1 mark. Next, calculate the percentage yield if 10.2 was produced 6.15 grams of cyclohexene. Right, okay. So again, the equation was needed here. It's a 1-to-1 ratio. Yeah, calculate the percentage yield if 10.2 grams of cyclo, so I've got 10.2 grams of him. Step 1, get to moles. Yeah, number of moles is grams over rams. Yeah, so I've got 10.2 over cyclohexanol. What's the MR of cyclohexanol? It's 100. Yeah, 12 times 6 plus it's water. Yeah, so it's actually 100. Yeah, over 100. So 10.2 divided by 100 gives me 0.102 moles. The ratio is 1-to-1. Step number 2 is 1-to-1. So I therefore have 0.102 moles of hexene, of cyclohexene. Yeah, of cyclohexene. Right. Now we need to work out that in mass. So number of moles times by rams gives me grams. We've already done the hard work. We know that cyclohexene weighs 82. So 0.102 times by 80, yeah, is going to equal 0.1 times by 80 gives me, I should have made 8.16 grams, but I actually made 6.15. Actual over calculated over 8.16 times 100. 6.15 divided by 8.16 times 100, and I get an answer of 75.4% yield. That was hard, that, folks. Wow, all that for 2 marks. Jeez. Guys, that's scary. Unfortunately, that's A-level for you. Yeah, 3 marks for that guy. What a nightmare. Next, all of these now become 1 markers, which is nice. Bioethanol can be made by fermentation of glucose. The atom economy by mass for the production of ethanol is, right, ethanol. So this is wanted over the total. Guys, I know this seems really funny. I know the MRs of every single person in that equation. Glucose, 180. If you have me for GCSE, you'll know that. Yeah, it's just whenever I watch darts, whenever they get 180, I'm going, glucose. I know that's really nerdy. I'm really sorry. 180.0 to be exact. Ethanol, of course, is 46. It's one of my favorite chat-up lines. You know, go to a bar. Can I buy you a drink of MR46? Yeah, that's one of my favorite chat-up lines. Carbon dioxide, of course, is 44. 44.0. I know it's so sad that I know all these things, but you get used to them. You see them so frequently that they just happen. It's just ones that you kind of slowly can't start to pick up. So in this case, I've got 2 ethanol. So we want the atom economy is percentage atom eco is wanted MR over total out times 100. Right, well, the wanted is 2 ethanols. Notice the equation. I have 2 of them. Yeah, so I have 46 times 2 over total out. Oh, I shouldn't really do, well, I can do that for life, that's fine. Over 46 times 2 plus 44 times 2. Yeah? Over 46 times 2 plus 44 times 2. Yeah? 46 times 2, lads. That there, I'm going to erase that, get rid of that and put in proper number, 92. And then 92 plus 44 times 2 is 88. 88 plus 92 goes to 180. Well, 92 over 180 times 100. I don't know why I've gone London, but I've gone London. Don't mean to do it. Sorry, lads. 92 divided by 180 times 100 gives me 51.1%. So I'm going to have 51. It's B. It's B, lads. It's B. I don't know why I've gone London. Don't know why. I haven't done a London accent in ages. Anyway, moving on. Right. The percentage atom economy by mass for the production of phosphoric acid from phosphorus is Oh, multiple equations. I warned you. Yeah, so this is a bit of a nightmare. So here's how I would do it. The equations can be combined. In order to work out atom economy, you need a single equation. So combine these two. That cancels with that. Total equation, P4 plus 5 O2s plus, that's a 5, plus, it looks like SO2, you see, doesn't it? There we go, 5 O2s plus 6 water. Waters, lad. Sorry, I keep doing it. Sorry. Goes to 4 phosphoric acids. You can combine the equations to get a singular equation. Now we can work it out from phosphorus to phosphoric acid. Oh, guys, it's 100%. There's no other product. How easy is that? Looks hard, but it's not. Combine the equations and there's no other product. So it's 100%. Amazing. Moving on. The ionic equation for the reaction between hydrochloric acid and aqueous sodium hydroxide. Go. Done. Yeah, we know that this is a neutralization. That's the ionic equation. So that cancels out with, oh, hang on. By the way, this one is the correct one. But then what we realize is that cancels out with that and that cancels out with that because they're aqueous and we just end up with A. So the answer to 4 was A. Nice and easy. Next. Oof, okay. Phenol is converted into trichlorophenol according to the following equation. If 50 grams of phenol produces 97.6 of TCP, what is the percentage yield? And they've given us all the MRs. How lovely of them. Why, thank you. Why, thank you very much. So we want to do, this is percentage yield. Yeah? So they're saying 50 grams of this guy is making, so this is the real, yeah, real output, 97.6. The question is, what's the calculated? Yeah, what's the calc? Right. The ratio, so number one is, step number one, get to moles. Number of moles is grams over rams. Well, what I've got is 50 grams of phenol. Yeah, so 50 divided by the MR of phenol, which it's given us, which is 94, which is there. Yeah, 50 divided by 94 gives us 0.532. Okay, next, it's a 1-to-1 ratio. Step 2 is 1-to-1, because from there to there. So I would have also got 0.532 moles of trichlorophenol, which has an MR of 197. So I'm going to do grams over rams reorganized, times by the rams of 197.5. So times that by 197.5, and I should have made 105 grams, but I actually made 97.6. So 97.6 divided by answer times 100, and I get 92.9%. It's D. Done. Next, got 6 minutes to finish. How many questions have I got left? Oh no, I think we're nearing the end, aren't we? Yes, we're nearing the end. Okay, next. What is the minimum mass of iodine required to produce 1 kilogram of phosphorus iodide when phosphorus is in excess? Molar mass of phosphorus iodide. Okay, so they've given us a kilo. Number of moles is grams over rams. That's 1,000 grams of phosphorus 3 iodide. Yeah, and phosphorus 3 iodide is there, 411.7. They've given us the MR. Grams over rams, 1,000 divided by 411.7. Yeah, and I'm going to get 2.43 moles of phosphorus triiodide. Yeah, and it says, what is the minimum mass of iodine? Ratio. Step number, that's S1. Step 2 is the ratio. The ratio is 4 to 6, and we're moving in that direction. So take that number on my calculator, 2.428953121. I'm going to divide that by 4, divide by 4 times by 6. Divide by 4 times by 6. And I get, therefore, 3.64 moles of iodine. And then it says, of course, it wants me in kilograms. Iodine, got to look it up on the periodic table, 137, 36, 136.7. I don't know. Oh no, I'm going to be so close. 126.9. I was miles away. 126.9 times 2, 126.9. So that's iodine. Iodine is equal to 126.9 times by 2. I'm going to lose it on my calculator. Multiply that by brackets 126.9 times 2. Go. I get 924.7 grams. Divide that by 1,000 to put me into kg. 0.925 B. Number 6. Number 7. Okay, what is the maximum mass of disulfur dichloride? Ooh, that can be produced by the reactions of 0.1 moles of sulfur and it's an excess reagent. That's today's lesson, folks. That there is today's lesson. We've been given 2 sets of moles. We've been given 0.1 moles of sulfur. 0.1 moles of sulfur. Says I'm going to put mole. Yeah, 0.1 moles of sulfur and come on, my laptop's stuck. 0.394 moles, 0.394 moles of chlorine. Now, this is an excess reagent calc. They've given us 2. Now, so what we do is, it's not as hard as it actually seems. This is actually the methodology for doing it. Yeah? And the method says that you should cover somebody up. Just cover somebody up. I'm going to cover him up. Right, so if I have the ratio of this guy to this guy here is a 1:4. So if I do times 0.1 times 4, I needed 0.4 of it. How much do I have? The answer is not enough. Yeah, this is limiting. Not enough. So the chlorine is the one that matters. This is in excess. You ignore it. And the ratio of that is a 4:4. So I need I'm going to make 0.394 moles of S2Cl2. And it's then given us that as its MR, multiply that number, 0.394 times by 135.2, and I get 53.27, so it's C. That's excess reagent right there. Okay, ammonia is manufactured from hydrogen and nitrogen in the Haber process. If 60 tons of hydrogen produced 80 tons of ammonia, what's the percentage yield? Ooh. Okay. The numbers look awfully odd, don't they? I feel like there's a problem with this question. 8/30. They're going to have given me, I don't know actually. Leave it in tons. The ratio from hydrogen to ammonia is a 3:2. Yeah. If I put in 60 tons, divide by 3 times by 2. So 60 divided by 3 times by 2 gives me 40. Yeah. Times that by 17. 680. That's weird, isn't it? 680. I should have made 680 tons of ammonia. Oh, hang on a minute. I've made a mistake. No, 60 divided by 2. I'm an idiot. I didn't actually turn it into moles. I just did 60 directly into ratio, and I shouldn't have. 60 divided by 2, which is the MR of hydrogen, gives me 30 moles. Ratio is 3:2. So divide by 30 by 3 times by 2 gives me 20 moles of that guy. Times that by 17. That's better. I've gone mad. So 20 multiplied by 17 gives me 340. So I should have made that 340 over 8. So I've got a tiny yield. So hang on a minute. So 80 over 340. How do I simplify that? 80 over 340. 340 divided by 8 is 4.25. Don't like that. 30 over 80? It's not 30 over 80. 60 over 80. No. Oh, I don't know what's... Guys, there's a problem here. There's an issue. There's pictures missing. What it should have been, it should have been 80 over 340 and then simplify it. Divide them. It should have been 8 over 34 times 100. That's what it should have been. One of these pictures are incomplete. There's something missing. So you couldn't do that one. Don't worry about it. Last question for the homework, and I'm done. I know I've gone right to the edge. Really have. Sorry about this. The process for the highest... So by the way, ignore that one. That doesn't count. The process for the highest atom economy is, right, propene is cracked to form icosane. It's right, no. The answer is D. You're going to ask me how I know that. Because, guys, it's 100% atom economy. That one's 100%. Because if you take propene and you polymerize it, they all form one product. That means that D is the answer for to number 9. Cyclohexene to reforming to cyclohexane. Yeah, reforming means they're going to split it up and turn it into something else. Yeah. Reforming. by reforming hexane. Yeah, that's actually splitting hexane into hexene, making hydrogen as well. Chloro from propane is going to make hydrochloric acid as a byproduct. That's tricky on that, guys. Just ignore that one as well. Actually, you can have it. It's 1 mark. It was D. It's knowing that that one's 100% atom economy. That was tricky, that. So you could do that one. Let's just add up our marks for this one, guys. That was a hard homework as well. Blimey. It's taken me a full hour to do this lesson. Yeah, that one had 3. Then it was 1. 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 Then it was nothing. And then that one also. How many ticks in total? I don't know how many ones. 3, 4, 5, 6, 7, 8, 9, 10. It's out of 10, folks. It's out of 10. Go, go, go. Get your data in. It's out of 10. Oh, IP for Murdo. Oh. I know, and I haven't seen Angel either. Guys, that's it. I'm done. Get it in on the data. I'm going to leave you be. Holy moly, I've gone right to the wire again. In fact, I've actually crossed over into break time. I'm so sorry, folks. I didn't mean to. That was tough, that. Full hour for me to even do those homeworks. I hope you found it useful. I'll leave you be now. Have a great rest of your day, and I'll see you soon. Take care, guys.